Hey guys, good morning. Now, so you already checked if you have 10 points in front of your practice exam, that means everything is fine. If you have a question mark, most of the cases is the reason if you have 10 and check mark. It means like you submitted only one page. So that means like you need to be careful because exam gonna be 4 or 5 pages, if not more. So that means you should know how to scan it and upload it as a single PDF file. Because as you notice, Canvas allows only one file to be uploaded. And if you have zero, that means make sure do not get in trouble tomorrow because you're gonna have like only 10-15 minutes to scan and upload your work. Now, if you have any questions regarding practice exam, write the numbers in your in a chart so I can see like which numbers do you want me to go over it. So number 12. Any other question? 13, 16. Nine. Okay. So it seems we start from number 4. Sketch the graph of a function, example of function f that satisfies all of the given conditions. Okay, let's start from this one. So you have x approaches 0, x approaches 4, we draw it here. Okay, f at 4 is 1. 1, 2, 3, 4, 1. So this point is anagram. Approaches 4 from the right goes to 0. So that means you have this portion, something like this. From the left, it should approach to 3. 1, 2, 3. 3 is here. So it's from somewhere goes here. Now, f at 0 from the left goes to 2. So this is 2. F of x goes 0 from the right goes to 0. That's this part. So which can go get connected to this one. f at 0 is 2, so this one should be closed circle. That's it. That's number 4. Number 5. Find g of f and its domain. So g of f of x means f of x goes instead of x in g of x. So you have x plus 1 over x plus 1 over x plus 1 over x plus 2. Now multiply by x, so you get x squared plus, let's switch them, x plus 1, and this is x squared plus 2x plus 1. Now domain of f of g for f. Okay, domain of f, we have x cannot be 0. 0 union 0 to infinity. Domain of g is x cannot be negative 2. Infinity. Now, g of f, you start from domain of, so domain of g of f is, so start from the domain of f, so x cannot be 0, and f should be in the domain of g, but g cannot be negative 2. So you need to write f of x cannot be negative 2. So it's x plus 1 over x cannot be negative 2. X squared plus 1 cannot be negative 2x. So this is x plus 1 squared, cannot be 0. So x cannot be negative 1. So x cannot be negative 1. So it's negative infinity, negative 1, union negative 1 to 0, union 0 to infinity. That's 5. So
Did you write the final answer for the domain? I can see
that's
it.
the final answer below. Domain of g of f
On the
is
right
negative
side.
infinity to negative 1, union negative 1 to 0, union 0 to infinity.
Could you circle it? Is it? Oh, it's the interval notation in the bottom right.
Yeah.
Is that it?
Yeah. So this is your composition. This is final domain. Any question on those? No. Let me do this and go come back. Okay, number 4 and 5, we did 6. Evaluate difference quotient for the given function. So equals f of x is x plus 3 over x plus 1 minus f of 1. We can evaluate. F of 1 equals 1 plus 3 over 1 plus 1. 4 over 2 is just 2 minus 2 divided x minus 1. Now multiply top and the bottom by x plus 1.
Instructor, the side part that you did, um, so is that just a side calculation on the bottom?
Yeah. instead of f of 1, instead of putting 1 plus 3 over 1 plus 1, I just found f plus 1.
Okay, I see.
Now, when you multiply, the top will be x plus 3 minus 2 times x plus 1 over x minus 1, x plus 1. Now distribute numerator. So you get x plus 3 minus 2x minus 2 over denominator, which is 1 minus x over x minus 1, x plus 1 equals. Now 1 minus x is negative x minus 1. So you can divide out. So you get negative 1 over x plus 1. That should be your final answer. Number 6. Any question?
Professor,
Yes.
so I see on the second step when you multiplied the top and the bottom by the x plus 1, I actually found the common denominator for the top numerator part. All I did was multiply.
Fine. But you should get the same answer when you finish it.
That's funny. I actually got negative x minus 1 over x plus 2 times x minus 1.
You get negative x plus 1.
Okay, let me just check my work.
Because you have x plus 3 there, minus 2. Should be positive 1.
Thank you.
So if you do everything correct, x minus 1 should be common factors. You should be able to get rid of denominator. Now, number 7. Okay, let's do this. Evaluate the limit and justify each step by indicating appropriate words. So, first step, limit goes under the radical. So you have limit, x approaches negative 4x to the 4 3x plus 6. This is the first step. Second step, limit of the sum can be written as the sum of the limits. So you need to have limit of x to the 4, limit of 3x plus limit of 6, x approaches negative 2. So second step. Third step. Now, first one, we already can substitute. It's negative 2 to the power 4. Second, you cannot. You first need to take constant. The last one is just 6. 1, 2, 3. Now, fourth step. This is 16 plus 3 times negative 2 plus 6. And finish it. It's square root 16, which is 4. So 7 also we did. Now, 9. Determine the infinite limit.
Excuse me, Professor.
Yeah.
Do you want us to write the other two limit steps? Because I went from the first step to the first step with this problem when I did it on the practice exam.
Then you're going to get like 2-3 steps deducted. So each step is, in this case, how many steps do we have? 1, 2, 3, 4. Let's say the last one is getting the answer right. So each step, at least 2 points. So anything you miss, because there's nothing to do here. You can even strictly substitute. That's the requirement to show all the steps.
Yeah, because I did the first step and went.
But you need to. This one is a continuous on its domain. So that means we can substitute the number as long as it's in the domain. So you can directly substitute and get 4. But that's not the question. That's not a direction for the problem. The question is to show that you know the laws. The law is if you have a power, then you can take limit under the power. The law, if you have the sum of the functions, you can evaluate limit of each function separately. Then direct substitution for x to the 4, we have it. Constant, we have it. And if it's a constant time function, actually you do one more step. 3 goes out and then you substitute. Make sure it's not a hard problem, but it's easy to make a mistake. Anything you consider it's obvious or easy, you skip, you're losing points. And
Instructor,
it's a gift, this problem, if you have it on your exam. But if you don't do it right away, you lose really like too many points for no reason. Yes.
the laws, there's like many that are given. Now, are they like some that are very important that we have to know by heart, or do we have to memorize all of them? Or can we
You don't
use
need to
like note
memorize. You
cards?
just need to look at it and break it and show all the steps. So this is basically elementary steps, just like when you perform any operation in elementary algebra. So first you move one number to the other side, then add, then divide or whatever. So something like that. We're not going to use it. We just want to see that you know the rules. Don't skip any steps. See, limit x to the 4, x approaches negative 4. You can do even in 2 steps, but this one you can skip because we have another law for that one. Okay, number 9. So determine the infinite limits. X approaches negative 2 from the right. Now, if it's negative 2 from the right, you can, let's say approximately your x is negative 1.9. Now, numerator, see, denominator goes to 0, numerator goes to number. It is going to be infinity. But you just want to find out it's positive or negative. So numerator is negative because negative 1.9 minus 1 is negative. Denominator positive because it's squared and positive. So that means the answer is negative infinity, which means does not exist. So it says determine the infinite limit. So you know it's going to be infinite, but you just need to figure out the sign. It's negative or positive. And then right does not exist.
Instructor, how did you get the negative 19?
How do I get what?
The negative 19 on the side?
It's 1.9.
19?
Oh, that's 1.9. Oh, okay. Yeah, I got that
1.9.
too.
Yeah, it's
Right.
close to the 2, negative 2,
Yeah.
right?
Okay.
It's negative 1.9. Okay, 10. Evaluate the limit if it exists. Now, if h goes to 0, numerator is 0, denominator is 0. So that means h should be a common factor. Just square the numerator. If you're having the trouble, move it. Write h minus 5 squared minus 25 over h. H approaches 0. So this is limit. H approaches 0. H squared minus 10h plus 25 minus 25 over h. Now these two are gone. So the next step you have limit h approaches 0. So when you divide, you get h minus 10. So it's negative 10. So from this session, you're going to have, this just indicates you the session, you're going to have a lot of problems from here. Not a lot, but like probably 2 problems from here will be. Okay, that's number 10. Yeah, 11 and 12, definitely. I knew you were going to ask me. 5x minus 6. Okay, and limit of x squared plus 2x minus 10. 6 approaches 3. Okay, let's do 11 and 12 now. So 11, limit of 5x minus 6 equals 9 as x approaches to 3. So we start step 1. For every epsilon greater than 0, there is a delta greater than 0 such that if 0 is less than x minus 3 less than delta, then 5x minus 6 minus 9 is less than epsilon. So 5x minus 6 minus 9 is 5x minus 15 is 5 times x minus 3. This is 15, not 15, sorry. Absolute value of 5 times absolute value x minus 3. This is 5 times x minus 3. X minus 3 is less than delta, so this is less than 5 delta. So we choose, it should be equals epsilon. Delta should be 1 over 5 epsilon. First step is done. Now, second step, for given epsilon greater than 0 and delta equal 1 over 5 epsilon, 0 is less than delta, we have 5x minus 6 minus 9 equals minus 15, which is less than 5 delta, which equals 5 times 1 over 5 epsilon. So, absolute value 5x minus 6 minus 9 less than epsilon, which implies by epsilon delta definition, limit 5x minus 6 as x approaches 3 equals 9. Okay, any question?
Yeah, for the second step, I just use substitution. Is that not okay for that?
Whatever you have it. Second step is just repeating whatever you have below that like absolute value expression, but it says like a for given epsilon, and if you choose delta equals to this 1 over 5 epsilon, then it should work, and we're showing it works because that's how we choose, right? Delta, it should work. So we get, if you choose delta 1 over 5 over epsilon, then absolute value 5x minus 6 minus 9 will be less than epsilon. And by definition, the limit equals to 9. Now, it's the meaning is usually takes time to understand for a lot of students, but like you'll be surprised. Most of the students doing this proofs good like on exam because you just need to follow those steps. Algebra is not a lot. Just remember what we write there, write the same way. And the only algebra part will be changed. Let's say instead of 5x minus 6, you will have another linear function. X goes 3 would be different number, definitely result. Except the numbers, numerical part, rest is the similar. So you just need to remember those steps. I have no question, I'll go 12, next one. It's not 5. 5 delta, it comes from 5 times x minus 3, right? X minus 3 is less than delta, so 5 times x minus 3 is less than 5 times delta. Delta is in the beginning, the second row. If you look at the step 1, you already have it there. 0 is less than absolute value of x minus 3 less than delta. Okay, now 12 is quadrilateral. That one is similar except one step will be added. Now we have as x approaches 3 x squared plus 2x minus 10 equals 5. Okay, step 1. This is similar to the previous. For every epsilon greater than 0, there is a delta greater than 0 such that if 0 is less than x minus 3 less than delta, then absolute value x squared plus 2x minus 10 minus 5 is less than epsilon. So you have x plus 5, x minus 3. So this is x plus 5 and x minus 3 less than. Now x minus 3, I know it's less than delta, but x plus 5, I don't know how to put a number corresponding to this one. That's why we do the following. Let delta be 1. Then absolute value x minus 3 less than 1. So x minus 3 less than 1 greater than negative 1. You can do in one step, you can do in two steps. Let's say plus 3. 2 is less than x less than 4. X is between those two numbers. I need to estimate x plus 5. So add 5 to all three parts. 7 less than x plus 5 less than 9. So absolute value x plus 5 is less than 9. So I estimated x plus 5. So this is less than 9 delta. Make it equal to epsilon. So delta is 1 over 9 epsilon. But because we have another delta here, so you have delta 1 or delta is 1 over 9 epsilon. Then your delta equals minimum of those two, 1 and 1 over 9 epsilon. As long as epsilon is given, you can determine which one is smaller one, and smaller one will work. So this is the end of the first step. So you need to choose any value for delta, 1, 0.5, 0.1, anything you want, but 1 is convenient to estimate. Now, step 2, we have 4 given epsilon, and now we have delta equals minimum of, so we have 1 over 9 epsilon. So 0 is less than x minus 3 less than delta, and x plus 5 less than 9 for delta equals 1. We have, or we get, doesn't make difference, whatever you write, x squared plus 2x minus 10 minus 5 equals, so you get x plus 5, x minus 3 equals x plus 5, x minus 3, which is less than 9 delta, but delta is 1 over 9 epsilon, becomes epsilon. So x squared plus 2x minus 10 minus 5 less than epsilon implies, by epsilon delta definition, limit equals 5. And we are done. Any question on this one? Okay, let's see what 13 is. $11 we did, 12 we did, 13. Prove that limit of x for cosine 2 over x is 0 as x approaches 0. Okay. So we need to prove it using the squeeze theorem. So limit x for cosine 1 over x as x approaches 0 equals 0. Now we start from cosine x, 1 over x actually. This is less than or equal 1, greater than or equal 0.
It's cosine 2 over x.
2 over x. Let's make it 2.
No difference, but
yeah, no difference. So cosine is between -1 and 1. By the way, x approaches 0 means x is not equal to 0. And x to the 4 is greater than 0. Because x to the 4 is greater than 0, we can multiply all three parts by x to the 4. So you get negative x to the 4, x to the 4 cosine 2 over x less than or equal x to the 4. Now this is your
Mr.
f of x.
Pogosyan, is
Yes.
this number 13?
This is number 13, yes.
Okay, thank you.
No problem. This is your g of x. This is your h of x. Now, limit of f of x, x approaches to 0, equals limit of x negative x to the 4, 0 equals negative 0 to the 4 is 0. Limit of h of x, x approaches 0, equals limit of x to the 4, x approaches 0, equals 0 to the 4 is 0. Now by squeeze theorem, limit of g of x as x approaches to 0, which is limit of x to the 4 cosine 2 over x, x approaches 0 is 0. And we're done. So we estimated x to the 4 cosine 2 over x, it is between negative x to the 4 and x to the 4. Limit of x to the 4 is 0, limit of negative x to the 4 is 0 as x approaches to 0. That means limit of g of x, which is between those two, also 0 by squeeze theorem.
Instructor,
Yes.
on the bottom left, is that the last part, is that h of x?
So you have f of x, g of x, h of x. Any other question? No. Now 14. How would you remove the discontinuity of f? How would you define f of 2 in order to make f continuous at 2? Now, find the limit of f of x as x approaches to 2. So in order for removing discontinuity, it first of all should be removable, and the limit should exist, and it should be equal to the function value. So the limit is x cubed minus 8 over x squared minus 4, x approaches 2. So you have x minus 2, x squared plus 2x plus 4 over x minus 2, x plus 2, x approaches 2. 2 makes 0 numerator and denominator, so these two are gone. So you have equals limit x squared plus 2x plus 4 over x plus 2 as x approaches 2. Now you can do direct substitution. 4 plus 4 plus 4 over 2 plus 2 equals 8, 12 divided 4 is 3. That means f at 2 must be equal to 3. So when x approaches 2, limit is 3. It exists. Function value at 2 also should be 3. Then they are equal to each other. We have continuous at 2. That's number 13, no, 14. Any question on this one? Now, intermediate value theorem. Use the intermediate value theorem to show that there is a root of the given equation in specified interval. So we have a space here. So I can do it here. Okay. Now, cosine x equals x. Move to the left-hand side. You get cosine x minus x is 0. Now let f of x be cosine x minus x function. First, f of x is continuous on 0, 1. Now, second, f at 0 equals cosine 0 minus 0. This is 1, greater than 0. F at 1 equals cosine 1 minus 1. You can find the approximate value, but this is less than 0. 1 is a radian measure, remember, not degree. In both cases, you get less than 1. But like in general, whenever you have, those are radian measure. So it's less than 1. So f of 0 not equal to f of 1. Now, n equals 0 is between f at 1 and f at 0. So by intermediate value theorem, there is a C in 0, 1 such that f at C equals n equals 0. But this implies C is 0 of fx because f at C equals to 0. So that means it's one of the zeros of f of x. This implies C is a root of cosine x minus x equals 0 because that's our f of x, right? And this implies C is a root of cosine x equals x. And C is from the interval 0, 1. So by intermediate value theorem, there is a root of this equation in that interval.
What is n equals 0? Like, what is n?
And if you go to the theorem, intermediate value theorem says if n is between f of a and f of b, then there is a C. N is any number between them, but in this case, 0. So let's say this is f of a, this is f of b. So, and n is between them. Now it's a continuous function on closed interval. So that means if I draw the line from here, at some point it intersects. So this is C. So there is a C between A and B that f of C would be equal n. N is between f of A and f of B. But in our case, because they are opposite signs, so n I can choose equal to 0. See, if it's 0, it's positive, it's 1. If it's 1, it's negative, so that means at some point it should cross the x-axis. So in our case, if it's 0, it's 1. If it's 1, somewhere here, let's say negative number. This is cosine 1 minus 1. Let's assume this point here. Now, if you draw the line through here to here, at some point it should cross. N is 0. So that means we have a root there. So 16 is also go. So similar type of problems, guys. Practice similar type of problems. Anything you see here, similar ones will be on your exam.
I don't quite understand the cosine 1 situation. It says f of 1 equals cosine 1, right?
Cosine 1 minus 1, not cosine 1.
Oh, cosine 1. But how is this less than 0?
You have a calculator. Cosine is always between 1 and negative 1. So anything other than 0 or 360, let's say, will be less than 1.
I think you get like negative
Cosine 1 is cosine 1 is in radian measure, which means 57 something degree. So if you use your calculator, it will tell you.
Oh. Okay.
Yeah, it's 0.54 cosine 1.
See? If you remember unit circle, it's 1 only when it's 0, right? So if you draw here unit circle, cosine is 1 here, and when you go anything else, if you move, let's say a little bit, right? So it already becomes smaller, and 57 is somewhere here, 1 radian. 1 radian means the arc length is 1, so this part is 1.
Okay,
You can divide 180 by pi. So whatever you get, that's your 1 radian. So 1 radian is 180 degree divided pi. Because pi is 180 degree. So when you divide, you approximately have the degree. So 57 something or whatever you get, for that value, cosine is definitely less than 1. Any other question? Now, most of you did a really good job on your practice exam, so you see that point. So that means in similar way you are going to do your exam, but with a less amount of time. Let me see what other question. Can you go over number 8? Okay,
And
let's see what
you skipped 15, Austin.
Oh yeah.
8 and 15. Okay, let's go back. What's 15? Explain why the function is discontinuous at the given number a. Okay. Now, limit of, let's change the color, f of x as x approaches to 1 equals limit as x approaches 1. Notice that f at 1, first condition is fine. F at 1 is 1. We have it. Now second condition. So this one equals limit x times x minus 1 over x minus 1, x plus 1, x approaches 1 equals x minus 1 divides out limit of x over x plus 1, x approaches 1 equals 1 over 1 plus 1, which is 1 over 2. So the limit of f of x approaches 1 is 1 over 2. But Third condition, limit of f of x as x approaches 1 not equal to f of 1. That's why it has a discontinuity. So third condition is broken. Function value exists, limit exists, but they are not equal to each other. That's number 15. Question? Now let's see what it is about. 8. Okay, let me stop sharing, then start sharing. See if it goes away. Yes. Perfect. Okay, x approaches 0 from the left. Now, when x approaches 0 from the left, means x is less than 0. Absolute value of x equals negative x if x is less than 0. So this one equals limit x approaches 0 from the left, 1 over x minus 1 over negative x equals limit x approaches 0 from the left becomes 2 over x, which equals, now x is less than 0, it's negative, and it approaches 0, so it goes to negative infinity. Does not exist. So if it was from the right, we did from the right. So absolute value of x equals x if x is greater than or equals 0. Now x approaches 0 from the right, x is greater than 0. So in that case, if you have limit as x approaches 0 from the right, 1 over x minus 1 over x. This is limit of 0, x approaches 0 from the right, it's just 0.
I have a question here.
Great.
What happened, like this absolute value, isn't it like every time you put the absolute value, it's always a positive number?
Right, but if x is negative and I need to drop the absolute value symbol, it becomes negative x to make it positive. That's the definition. See, absolute value of x, equivalent saying x if x is non-negative and negative x if x is less than 0. You should get positive. So absolute value of negative 5 is 5. So
Yeah.
absolute value of negative 5 is negative 5, which is 5. So if I know for sure x is negative, I can put minus in front of it, becomes positive. And if x goes to 0 from the left, it's negative, right?
Yes.
That's what we meant by writing negative x instead of absolute value of x.
A quick question. It says
Yeah.
it's approaching 0 from the left. The answer is does not exist or negative infinity.
No, negative infinity means does not exist. You can have does not exist because if it says x goes to 0, right? For example.
Yes.
See, from the left, it's negative infinity. From the right, it's 0. It just does not exist. We cannot put anything. See, limit, if it was same thing, or where we have it, 1 over x minus 1 absolute value of x, x approaches 0. We need to split left, right. Now, from left, it's negative infinity. From right, it's 0. We just put does not exist because we cannot put anything there. But negative infinity, we can put there. It's infinite discontinuity. But it's discontinuity. It does not exist. Infinity is not a number. But if you can determine, you need to write it. Say if the graph goes, let's say, this type of graph from the left, from the right, it's infinity. Let's put here 2, for example. So this is 1 over absolute value x minus 2. So the limit goes to infinity as x approaches 2 from right or left, but it does not exist. Now, if it was something like this, again, this is 2. Let's assume from this part goes this way, from this part goes this way. Now, in this case, the limit of f of x just does not exist because from left it goes positive infinity, from right it goes negative infinity. They are not equal. But the first example, we can put infinity.
So basically, they have to go to the same direction.
In order to determine if it's infinity or negative infinity. But it still does not exist because infinity does not exist. But if they go to different direction, you don't even put anything because you cannot put either one.
So
It
even
just
for the
does.
first one, you would write in positive infinity, and then you would write DNA.
Yeah. DNA does not exist.
For example, for 8 was just asking for the infinite limit. Would it be negative infinity at that time?
If it asks you just a limit,
If it asks you for the infinite limit,
they don't, yeah, if they ask you, it would be again negative infinity, again does not exist. You can put does not exist, nothing wrong with that. Don't worry about that. If it's a infinite, negative infinite, or none of them, but you just put does not exist.
So every time we get an infinity,
It does not exist.
okay, that's basically every time we get an infinity does not exist comes with it.
Yes,
Okay.
because infinity does not exist.
Okay.
Any other question?
can you go over number 3? The f plus g is odd.
Mm-hmm. Okay, f and g are odd functions. F plus g is odd. Justify your answer is. Okay, so let's go here. F and g are means f of negative x is negative f of x, odd. G of negative x is negative g of x, odd. Let, it says, what was the question? Is the sum, right? Sum is odd. Okay. So we construct a new function. H of x is f of x plus g of x. Actually, sum, let's do this one. Now, h of negative x, which is f plus g of negative x, that's f of negative x plus g of negative x. Both of them are odd. Equals negative, we can factor out. You get f of x plus g of x, which is negative h of x. So what's the conclusion?
It's odd.
Yes, except which case? if f of
there-
x, yes, negative g of x, if they are opposite of each other, we get what? F of x plus g of x is negative g of x plus g of x becomes 0. Both of them are odd. You can check, it's odd functions. So let's say x cubed, f of x equals x cubed, or g of x equals negative x cubed. Both of them are odd functions. But the sum is 0, which is even. So except the case when the functions are opposite of each other, if f of x is the opposite, so except, let's go from here, if f of x is the opposite of g of x, it's odd. But if they are opposite of each other, they cancel each other. So you get 0, which is even. Now I hope on exam will not be as tricky as this one, but something that you need to prove or show using h of x as a combination of those two functions will be some difference, product, quotient, or whatever. Then you will have it. So, but like for certain problems, we have some, let's say, exceptions. So you need to be careful with the exceptions.
Wait, I wanted to see, like, how did f of x here turn positive? F of negative x, and then it's just f of x.
Negative f of x plus negative g, you factor out minus.
Oh, you factored out the minus?
Yeah, then you get f of x plus g of x. Its minus is here. It does. F of negative x becomes negative f of x because it's odd.
So then, therefore, h of x is negative.
H of negative x is negative h of x.
So it's odd.
It's odd, yeah.
And then it says
that's why
except.
We put answer yes. Except if they are opposite of each other.
Oh, if they're opposite of each other, then it's even, apparently.
Yes, yeah. But like it's compared all the functions, opposite will be a small amount. So let's say for this small amount, if you disregard, it's odd. So that means overall the answer will be what? Yes or no?
Yes.
No, actually it's no, because it says is f plus g odd? Not always, right? Or you need to write explanation. It's odd except those cases. Or it might be just no, because if there is a one case the rule is broken, that means you cannot answer yes. But the right answer probably will be yes, except if they are opposite of each other, because you need to confirm it. Why is not going to be always.
But let me just see exactly what the question says.
Mm-hmm.
Let me just see exactly what the question says there.
Actually, they ask you if this, and they ask you to explain. See, the problem says,
yes.
Is it, right? Justify your answer. Any answer you make, right? Like a yes or no. You need to justify.
Oh, okay.
We just justify that it's yes, but except those cases. So if we put no, we need to justify why. Again, you have to do the same work. So the work is the important part. And of course, the second important part, correct conclusion at the end.
Mr. Pogosian, is this number 16 the last one?
This is number 3.
Oh, okay, thank you.
No problem. Not less than 0. No, no, not less than 0. No, no, no. As long as they are not opposite of each other. No, how about if it's greater than 0? It's still fine. As long as it's not 0, you can say as long as the sum is not 0. You can say like as long as the sum is not 0, because sum is 0 when they are opposite of each other. Yeah, you can say that. Graph the function number 2. Guys, your time is over already. I'll really quickly show and finish it.
Mr. Pogosian, one more question. I just want to make sure that if we can use a small note for tomorrow.
Yeah, you can have it.
Okay, thank you.
Formulas, yeah.
You
Number
mean
2, you need to complete the squared.
Yes, note card is okay, I think.
It's 3 by 5 card, like a small card, put the formulas on it. So 3 squared minus 3 squared plus 4. So your y equals x plus 3 squared minus 5. Now you start 3 points here, here, here. So this is your first step. Y equals x squared. X plus 3 means 3 units to the left. So you move 3 units to the left. 1, 2, 3. This is 1, 2, 3. This is 1, 2, 3. So this is the second. And then shift 5 units down. So 5 units down. So this would be your final answer. So this is how you graph it. Okay, guys, if you will have more questions, like in 10 minutes, I'll open the office hours. Make sure do not be late tomorrow, because if you late like a 10-15 minutes, I will not allow you to take the exam. So exam is going to be on Canvas, exactly just like practice exam, but under the exam. So you go Canvas, but it will be open tomorrow morning, not now, definitely. And then when you finish, you go to the quizzes, it says exam number 1, upload it there. So when you finish, let me know that you're done. You can write it. So professor, I finished, I need to scan it. Then you can use your cell phone and do it. If someone doesn't have a camera, you can use your phone and get into the meeting using your phone and your computer, both devices. It's fine. So I'll let you in both devices. You can use camera on your phone, and you can just on your get in the Zoom like on a computer also, and go Canvas and find the exam.
Excuse me.
Yeah.
I think I was the only one who didn't get to do the practice exam for the simple fact that I thought it was today.
It's today.
What?
You didn't submit it? You mean like
No, I didn't take it, but it's like, so you have it on files is what I found.
right.
But then how do you submit it is the problem.
You go quizzes, Diego. You go the same way.
Quizzes?
Quiz, yeah, I'll show you right now.
And then it says take quiz, but it doesn't have
Right.
a
You
link.
click on that one, it says like a practice exam uploaded.
Oh, so yeah, you just upload it.
Right. But before that, you need to scan it.
Yeah, so the only problem I don't understand is the Exelon proof problems.
We did those two. If you want to come back like 11, like in 5-10 minutes, so into the office hours. You
Yeah,
know,
so I mean,
I'll
I don't know if you have time to show me personally how to do those, just because they're just
It's
too
personally, I'll
too
do it
complicated.
personally, but during the office hours, because I have another class, they have exam tomorrow too. So I need to right now finish with you, go to the office hours. I cannot
And-
stay on this page.
Which is at what time exactly?
It's like 11 o'clock. It's like
Okay,
in
thank
5
you.
minutes. Yeah, 5
Later.
minutes.
Professor, I just have one question. I'm currently in Mexico.
Yeah.
Yesterday I was having a little bit hard time because Wi-Fi and stuff was cutting out. Tomorrow I'm gonna be going back to Cancun to like fly back to LA, but we have to check out of here at I think it's around 11, which is around 9 o'clock your time because I'm in Tulum.
Mm-hmm.
So I'm not sure how the test is gonna work, but I'm assuming you're gonna just like the quiz. You're gonna put the questions on there. We have to just write it down on a piece
Yeah,
of
you
paper.
get into the Zoom meeting just like in your class time.
Yeah.
At the same time, when all you get here, I'll upload the exam.
Yeah.
So you can open it on Canvas and then do the exam.
My problem is if we check out of the house, I'm not gonna be able to like have service or anything because I only have service here because of the Wi-Fi at the house we're staying at.
Level,
So I'm gonna
then
try to figure out something that I can do. Maybe go
do
to
the
downtown
exam.
and use like a hotel or something.
I don't know. Do you have a hotspot or something?
I have a hotspot on my phone, but the service is very, very bad here because it's not like it's a small town. So we're just using the Wi-Fi to do stuff.
Anyway, so you should have been in classroom, not in Cancun.
I know, but it's for my birthday. I booked this trip, 5-6 months ago.
I don't know. Let's see what's happening tomorrow. Because if I open the exam and you don't take it at that time, it's open. So that means you cannot take it anytime later.
Yeah. Okay. We'll figure it out tomorrow. Then I just wanted to let you know what's happening, just in case if I don't show up, if I can get connected, you don't say like.
Grab one exam eventually. So.
What? Yeah, I know.
One
I just
exam
didn't want to,
Yeah, you don't want to drop this one. I know. Let's see how it works out tomorrow. Okay.
Okay. Thank you.
Let's wait until tomorrow. Yeah. Okay. No problem.
Okay. Bye-bye.
Bye-bye.
Thank you, Professor.
No problem.
Is that it for today?
Yeah, in 5-10 minutes I'll be there, like in office hours, basically.
All right.
So if you have any question, you can come there. It's in your syllabus. It says office hours. Link is there. You can use that one to ask questions.
Thank you so much, Professor. Bye.
Bye, Anil.
All right. Bye.
Bye, guys.
Get there, Professor.
No problem. See you.
Thank you. Bye.
Bye.